Hi, okay. Here we have a position time graph, okay? And we're gonna say that the object starts moving to north, okay? So, okay, let's analyze each interval on this graph. So the first interval is gonna be this, it's going to be this, and the second, yeah, the second interval, the third interval, okay, and fourth interval. Okay, so on the first interval, okay, remember that in a position time graph, we can calculate the velocity. Velocity is final position minus initial position, dividing by the final time, then the initial time. So the final position on the first interval is going to be 7 minus 1, and the final time is going to be 6 minus 0. That's going to be 6 divided by 6, and then 6 divided by 6 is going to be 1 meter per second. Okay, that's the velocity. Okay, that is the velocity on the first interval, 1 meter per second. On interval number 2, the velocity is going to be 7, because the final velocity is 7, minus 7, because the initial is going to be 7, 2, 10 minus 6. So that is going to be 0. Okay. And then the interpretation of this velocity, or this calculation, is that the object doesn't move. Okay, the object doesn't move. Very good. On the third interval, here the final position is going to be 0. The initial position is going to be 7. The final time is going to be 12. And the initial time is going to be 10. So that is minus 7 divided by 2. Minus 3.5 meters per second. Yeah, very good. Okay, the interpretation here. Okay, this minus says that the object is moving to south. Okay. And yeah, I forgot this plus, that is number 1 on the first interval, and the velocity says that the object is moving to the north. Okay, is moving north. Okay, so very good. Okay, so that is in the interpretation here on the signs for each velocity. Okay. Okay. Very good. Now, on the fourth interval, okay, the final position is going to be 0, minus 6. The initial position is 0. The final time is 15. And initial time is 12. So the velocity is going to be minus 5 divided by 3. And that is going to be minus 2 meters per second. And yeah, of course, is that the object is moving to south. Okay. Yeah, we have to do two more interpretations here that are important. For example, this one, that point on the time is 12 seconds. When time is 12 seconds, the 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 region, or no, sorry, the position is 0. Okay, and that means that the object is in the origin of the coordinate system. Remember that a coordinate system is a point on the space that we do all the calculations and measurements. For example, here, for example, I don't know, let's say, for example, that the object is a car, okay, and we have a stop sign here, okay, stop. So the graph is very simple. The object starts moving 1 meter to the north of that stop sign. Okay, here the object starts moving. Okay, so arrive to 7. Okay, arrive to, let me see, arrived to 7 meters here, for example. Okay, we have 7 meters. Okay, imagine that. And then the car stops. Okay, here it stops the car. Okay, so the final, the final velocity here in 7 meters is going to be 0. Okay, and the car stays stopped from the next 4 seconds. And then the driver took the decision to turn back. Okay, that is the meaning of the third interval. Okay, so he goes now on the opposite direction, and when the object is going to the region, arrives to the stop signal 12 seconds after the initial movement. So here the car is in the stop signal at 12 seconds. That is a position equal 0, because this is my coordinate system, the stop sign. And then for the next 3 seconds, the car continues moving to the south. Okay. Yeah, that is interpretation here of the entire graph. Okay. Now, if I want to calculate the total distance, that is going to be easy. To calculate the total distance is the addition of 6. Why 6? No, this 6. No. 7 minus 1, the distance that traveled the car here on the first interval is going to be 6. 0 on the second interval because the object doesn't move. 7, yeah, because the distance between this point and this point on the y-axis is 7. Look at this, from 7 to 0, 7. And the end is going to be -5, -6. That is going to be 6 because remember the distance always, the distances will always are positive. So this is going to be 19 meters. Okay. And the total displacement, okay, oh, look at this. The total displacement here is going to be, okay, here, 6 meters to the north, okay, is for the first interval. Then the object stops, then go back 7 meters to the south, okay, so we have 6 meters to the north, 7 meters to south, okay, south, and then 6 meters south again. So yeah, we have to do first an addition between these two numbers because they have the same direction. Okay, that's going to be 13 meters to the south, and then do a subtraction between 13 and 6. So 13 minus 6, yeah, that's going to be 7 meters. And then the direction, yeah, this is going to be 13, right? Okay, 13 meters to south, and we have 6 meters to north. Yeah, the resultant is going to be 7 meters to south. Okay, and yeah, look at this. The car is here, south from the stop signal. Okay, because the object starts moving first to the north, then it stops, and then turn back to the stop signal. 12, there it is. And the final movement is going to be 6 meters more to the south. So yeah, 7 plus 6 is going to be 13 meters to the south, minus 6 meters to the north is going to be 7 meters to the south. And that's it. Yeah, we finished. Very good.